Good morning again, Year 8. It's now Thursday. This is the last lesson of the week when we'll be doing normal curriculum maths. Tomorrow we'll do some maths challenge stuff. To finish the week off, I wanted to round off the bearings by you having a go at this sheet here, which I have in front of me and is attached to the lesson. I'm not going to be about the bush. This is actually a challenging sheet for you, and you will find some of the questions on here will really make you think, but I think you should be able to have a fair old stab at it. What I want you to do is to have a go at the sheet now to the best of your ability. It's all about calculating bearings for various diagrams that are given on the sheet. Get as many of them done as you possibly can. And then continue to watch this video, because I am now going to start to run through the answers to this sheet. Obviously don't keep watching the video now if you haven't already done the exercise. You do that first and then you come back and watch the rest of the video. So if you're going to pause the video, now is the time. Okay, I'm still here and I'm about to run through the answers to this sheet. So take them one at a time, and for some of the questions I'll write on the sheet, for some of them I'll do it on a piece of paper so I can explain what's going on. So here we go. Question 1. An aeroplane sets off on a bearing of 028 degrees, notice 3 figures, but after some time it turns back. On what bearing must it travel? Okay, well there were some questions on the Hegarty Maths that were a bit like this, so hopefully you were okay on this one. So here's the aeroplane. This is only a rough diagram, but 28 degree would be sort of in that direction. So that's what it's currently travelling on. Okay, so that's the direction that the plane is currently heading in. That's 28 degrees. And if it wants to go back to the airport, it's got to go in that direction, turn around and go back the other way. So the question is, what bearing is that? Well, that is going to be that 28 degrees plus an extra 180 degrees around there. So the total to that would be 208 degrees. So the answer to the first question, just doing red so it's nice and clear, is 208 degrees. One down. Next question. A ship sets sail on a bearing of 163 degrees. Again, let's just do a little diagram just to roughly see what 163 degrees would look like. Well, it would look something like that. That would be 163 degrees there, and this would be the direction that the ship is sailing in. That's north there, I should say. Okay, so it's heading in that direction there, and it turns, so it's going down here and it turns through an angle of 90 degrees anti-clockwise. Okay, so somewhere along here it makes a turn, and that turn, instead of keeping going in that direction, it turns to go in that direction. There we go, it's made a 90 degree turn anti-clockwise. And if you were to do the bearing here, well obviously that's 163, so you just take the 90 off, simple as that. You take the 90 off the 163 and that's going to be 73. Of course I write 073 degrees like that. Okay, so that's the first two dealt with. The next one I can actually do on the sheet, I think, probably. So we've got an equilateral triangle, and we're told that B to C is east. So going from there to there is to go east. And I've got to find various bearings on the diagram. So, slurp of my tea there. A from B. Well, what's going to help with this question, I think, is if we put some information on the diagram first. So I know that all these angles here are 60 degrees. Okay, so that's the first thing I'm going to do because it's an equilateral triangle. And let's think about what we're being asked to find. A from B. So that is the bearing of A from B. So I'm standing at B and I'm trying to get to A. Okay, if you watched my video from the bearings lesson yesterday, you'll know that that's what that means. I'm trying to get to A from B. So I'm stood at B and I'm trying to get to A. So the bearing I need for that one is that angle there. Okay, well that's east, that's north, so that must be 90 degrees. That little angle in there, which is the bearing, must be 30 degrees. So on the diagram, if I put 30 degrees there, so that would be 030 degrees. Okay, moving on. C from A. So now I'm stood at A, and I'm trying to get to C. So that would be to travel in that direction. So the bearing I need is this angle round here. Okay, well, a look at the diagram should convince you that that angle around there is the same as that angle around there. Therefore, all I need to do is to take that away from 360, which is 300, and then share it equally between these two angles. Put that angle in there so you can see what I'm talking about. So that and that must add up to 300, so they must be 150 each. And as I want the bearing of C from A, here's A, I'm trying to get to C, it's that one round there, so it's 150 degrees. Finally, A from C. So I'm trying to get to A, here's A from C. So I need the angle all the way around here, including that extra bit there. So around there would be 270, and then I've got an extra 60 degrees to add on to that. So 270, put the 270 on the diagram so you can see, plus the 60 would give me 330 degrees. I don't know if you've spotted it yet, but there is a relationship between A from C and C from A. They're always 180 degrees apart. The same thing happened on the first question here. They're 180 degrees apart. So if you know the bearing in one direction and you want the bearing in the reverse direction, you either add 180 on or you subtract 180, depending upon whether the one you're given to start with is more or less than 180. If it's less than 180, you add it on. Of course, if I'd been given that one and asked what's the direction in the other, I would have taken 180 off. Obviously, adding 180 would have taken me past 360. So all connected by 180 degrees, which kind of makes sense if you think about it. Moving on to the next one then. Question 4, I think I can do this one on the diagram as well. So what we have here is a map with the relative positions of 3 places: Belfast, Dublin and Liverpool. And similar to the last question, just not in an equilateral triangle, I've got to find various bearings. So the first one is Belfast from Dublin. Oh, that's very easy, because they've told you. It's on the diagram already. The bearing of Belfast from Dublin is this little tiny little smidgy angle in here, 6 degrees. So it's 006 degrees, not quite James Bond. 006 degree, one of his partners, one of his colleagues. Okay. Belfast from Liverpool. So Belfast from Liverpool means I need to draw my north line at Liverpool because I'm trying to get to Belfast from Liverpool. Oh, and this is similar to this one here, in that I need to go all the way around there and the extra 38. Well, that's 270. Add 38 makes 308 degrees. Okay, and then Liverpool from Belfast. Well, I was talking about this not that long ago on the previous question. Liverpool from Belfast, I just draw on the north line. That would be this angle around here. Okay, and well, I could show you how to calculate it by extending that line there, like so, and then realizing, I'm going to get this right now, I'm going to mess this up now, what I'm trying to say. What am I saying? Yeah, if I were to extend that line there, sorry, then the angle I'm looking for is the same as that angle around there. Okay, and I can work that out from the information around this one here. So I'm actually looking for that angle around there. Okay, and I'm messing this up now, sorry. Better way of doing it. Draw a line across there, and then it's going to be 90 plus the 38, because that there would be 38. So it's 90 plus 38. Well, I've made a right mess of that. 90 plus 38 is the correct answer, which is going to be 128 degrees. However, forget all of that, because there's a much easier way of doing Liverpool from Belfast, if you know Belfast from Liverpool, which is what I was going to do to start with, I should have done, and that's what I told you here. If you know the bearing in one direction, to get the bearing in the other direction, you either add 180 or subtract 180 from that value. And if I subtract 180 from that value, what do I get? 128 degrees, as expected. So I made a right old pig's ear of that. But that's the angle you actually want there. But you have to do some sort of parallel line thing to realise what it actually is. So if you draw a line across there, that's 38, that's 90, add them together is 128 degrees. But it's much easier to do it that way there. Okay, question 5. Ooh, a regular hexagon. Now this kind of links with our work from when we were doing interior and exterior angles of polygons, because the exterior angle of a hexagon is 60 degrees, because there are 6 angles and they add up to 360. The interior angle, which are these ones around here, well, if you remember, they, together with, here's an exterior angle to show you one, that's 60 degrees there. So that and that together add up to 180. So each of the interiors must be 120 degrees. I'm just going to put that on the diagram, because I'll probably need that fact to answer these questions down here. So here we go. We've got to do A from F. Well, A from F is that angle there, and that's one of the exterior angles, so I can see straight away that that is 60 degrees. Okay, C from B. So I'm trying to get to C from B. If I draw my north line at B, where I am, trying to get to C, so that's that angle around there, 180 degrees. Don't need to do much work for that one, it's straight down the page, south if you like, so it's 180 degrees. D from C, so I'm now stood at C and I'm trying to get to D, so that would be that angle all the way around there, and as you can see it's 120 inside the hexagon there, so all the way around there must add up to 360 with the 120, so that must be 240 degrees. And finally, E from B, okay, so E from B would be, so if I need to draw a line on the diagram for this one, it's to go down there, trying to get to E from B, so it's this angle all the way round to here. Well, this line here is cutting this angle into 2 parts, so it must be this angle around here. It's the same as the last one. Okay, and if you look at the diagram, you can kind of see that, because D from C is going in that direction, and E from B is going in that, and they're the same direction. These 2 lines here are parallel. Okay, put a little parallel thing on the diagram. So it makes sense that the bearing for this one is the same as the bearing for this one. And you can see it's 180 plus half of 120. So that's going to be 240 degrees. Again, the same as the previous one. Okay, final question then. Okay, another diagram. Should be able to do this one on here. It's another one with 3 places and some angles given to you. So let's have a look what we've got to do. We've got to do the bearing of Bardsley Island from Aberystwyth. So Bardsley Island is here, Aberystwyth is here. This one looks like it might actually be quite difficult, but let's give it a go. I'm doing this live. I haven't actually looked at these questions, so let's have a look, see if we can do this one here. So I need to draw a north line at Aberystwyth like that. And the angle I'm actually looking to find is the angle all the way around here. Okay, I'll just draw it on the diagram. So this angle all the way from that north line, sorry, all the way round to there, like that. And it's not immediately obvious how you're going to find that angle. There is quite a little bit of work involved in doing it. So I'm just going to take you through what you have to actually do. The first thing you have to do is to find this angle here in the triangle. Now that's okay because it's in a triangle and I've got two angles in the triangle already. So I've got a 55 and a 33 and they add up to 88, which means that this angle here, my maths is correct, must be 92 degrees. Okay, now this is where it gets a bit tricky because 84 and 92 don't add up to 180. They add up to 176 degrees. The reason they don't add up to 180 is because this line here is not straight down the page. There's a very small, if I just draw a line in there, there's a very small little angle here that makes it all add up to 180. And if my maths is correct, that little angle there is 4 degrees. Okay, this is a tough question, this one, no doubt about it. Now, if you look here, we've got a pair of parallel lines, these two, and we've got that alternate angle thing going on from the lesson I did on parallel lines with you. Was that earlier this week, wasn't it? So that means that that little angle in there is 4 degrees, which means, consequently, that that angle from that north line round to there is not quite 55 because it hasn't got the 4 extra, so it must be 51 degrees. Oh, this is complicated. And because that's 51 degrees and I want the angle all the way round there, that angle all the way round there must be 360 minus 51, which is 300. And my maths has gone 309 degrees. 360 minus 51, 309 degrees. My maths is back. So it's 309 degrees is the bearing of Bardsey Island from Aberystwyth. Yuck. Barmouth from Aberystwyth. Hopefully this one's not so bad. So Barmouth from Aberystwyth. Praise be, this one's easy. Having done all the work already. Barmouth from Aberystwyth is just this little angle in here. So that one is 4 degrees. Another relative of, colleague, sorry, of James Bond. 004 for that one there. And then what have we got? Bardsey Island from Barmouth. Don't know if this one's going to be easy or not. Let's have a little look. Oh, thank the Lord. I think we've done all the hard work already. Bardsey Island from Barmouth is going to be this angle all the way around here. In fact, this one's really easy because you can just use the 84 degrees for this one. It's all the way around here. So it's going to be 360 minus 84. I'll just draw on what it is. It's that one all the way around there to get to Bardsey Island from Barmouth. So it's just 360. Take away 84, which is going to be 276 degrees. That's right, isn't it? Doubting my maths now. Yeah, I think that's right. Okay, so 276 degrees, and that's it. Don't worry if you couldn't do all of those. It's a pretty tough sheet, but if you could do them, or at least you'll follow it, having watched my explanations there. Sorry about that one. I made a right old pig's ear of it, to be fair. But other than that, hopefully that was clear and you understand. Feel free to send me a picture of your work or just write me a comment when you turn it in to let me know what you thought about these questions. Were they hard? Were they easy for you? Probably hard, but I'll be interested. If you feel you've got the topic, really understand it, let me know. I'd be interested to find out at this stage. Sorry it was such a long video. It was a technical sheet to go through, but hopefully some of you have made it this far and are still listening to me now. Thank you for that. And like I say, we'll have a break from the normal work tomorrow and do some maths challenge or something else. Thanks for listening and have a good day.